This is lesson 5.6, Proving Triangle Congruence by ASA and AAS. So today we're going to talk about the last two methods to prove the triangles are congruent. So the first one is called ASA, and it stands for angle, side, angle. So with angle, side, angle, we're looking at two angles and the included side. So included side means the side that's between the angles. So if angle A is congruent to angle B, right, that's an angle. Side AB, or segment AB, is congruent to segment DE. That's a side. And angle B is congruent to angle E. That's an angle. Notice when I connect my two A's, I draw the side between the two A's. That is the side that's congruent. Right? Draw the side between the two A's. That is the side that's congruent. So we could say triangle ABC is congruent to triangle DEF. Right? That's ASA. Right? So let's look at a proof. Right? So we're given that segment BD is congruent to segment BC, and segment AB is parallel to segment BC. So that's the first thing they showed us, right? This is number one. That's given. And anytime they tell me like parallel, I'm going to have some congruent angles. And if it looks like a bow tie, I'll have alternate interior angles. So they're talking about angle B here and angle C. And if I were to connect them, my parallel lines with my transversal, those are alternate interior angles. That's the alternate interior angle theorem. Then they want the other units. We're going to include the fact that segment BB is congruent to segment BC. And the next thing is we want to use the vertical angle theorem. So my vertical angle is happening here. So that's angle ABC is congruent to angle EBC. We can't call it angle B because there's a lot of angles happening in B, so we have to be more specific with those. So looking at my problem now, there is a side here. This is an angle that's congruent, and this is an angle that's congruent. If I look at the letters, that's ASA, so like triangle ABB is congruent to triangle EBC. All right, so you try this. You're not going to have to write a full proof, but determine if you can prove the triangles are congruent based on the information given in the diagram, which would be that WX is parallel to YZ and XY is parallel to WZ. So if it's possible, state what theorem you would use. Pause when you're ready to see the answer. All right, so in this picture, angle 4 and angle 2 are congruent because they're alternate interior angles based on WX and YZ being parallel. Angle 1 and angle 3 are congruent because they're alternate interior angles based on XY and WZ being parallel. And then we have a reflexive or shared side at YW. So now that's ASA. So the triangles can be proved congruent by ASA. Our next method is called AAS. So it has the same letters as ASA, but now the order is angle side instead of angle side angle. So we're told if angle A is congruent to angle B, and angle B is congruent to angle E, and segment BC is congruent to segment EF. So let's look at this. Here's an angle, here's an angle, here's a side. I connect the two angles. That's not what the S does. The S is separate S, which is why this is AAS as opposed to ASA. So we could still say that triangle ABC is congruent to triangle DEF. So let's do a proof. We're given two things. First, we're given that segment HF is parallel to segment GK. So we're going to given. are my parallel sides, and I connect them with my transversal. These would be like congruent angles, right? Like your angle theorem. So it's angle FHG and angle KGH. We're also given that angle F and angle K are right angles. And the right angle congruence theorem then says we're talking about right angles being congruent, so that means angle F is congruent to angle K. Now we have HG is congruent to GH. That's the same segment in this picture, right? That's the shared or reflexive side. So that's congruent by the reflexive property. And now we have enough to say that the triangles are congruent. We have our right angle, we have our alternate interior angle, and we have our reflexive side. So that's AAS, right? Connecting the two A's is not the S. So the triangles are congruent by AAS. So let's look at these four. Determine if triangles can be proved congruent, if possible, by either SSS, SAS, ASA, AAS, or HL. So we could use any of the methods we've now learned. So generally speaking, what I would do is before I do anything, I'm going to mark any reflective side. So that has a reflective shared side, and that has a reflective shared side. And I'm going to mark any vertical angles. So we have vertical angles here, and we have vertical angles here. Notice I'm using a marking that wasn't already used yet. They already used 2 in here, so I'm using 1. They already used 1 curve here, so I use 2, and so on. So now, let's mark what we have. In this one, that's an angle here, a side here, and a side here. And the A is not between the S's, so it's not SAS, which makes it look like ASS, which is not allowed. But we have right angle, which means that this is really a hypotenuse, and this is really a leg. So this is yes, and it's HL. All right, our next one, we have side, an angle. We have 2 angles on a side. The S is not between the 2 A's. It's outside of the 2 A's, so that's AS. All right, next one, we have an A here, an S here, an A here. So if I connect the 2 A's together, it passes through the S. So this is yes by ASA. And our last one here, that's a side, that's an angle, that's a side. If I connect the 2 S's, it touches the A, so the SAS, let's just make sure the other side matches. Connect the 2 S's, A is in the middle. So this is yes by SAS. Go ahead, you try the last set, determine if they can be proved congruent, if possible, by any of our 5 methods. Pause and hit play when you're ready to see the answer. All right, so in part A, we see our reflexive side we can mark congruent, giving us ASA for those triangles. For B, I could also mark the reflexive side, now giving me side, 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 or SSS. Part C, there was nothing additional to mark, but we did have 2 angles on a side, and the side was not included, so that was AAS. And D was not possible because I had 2 sides in an angle, but the angle was not the included angle. It was not between the S's. So that would look more like ASS or SSA. And since they weren't right triangles, I cannot use HL. And that is the end of 5-6.